So let's put some numbers into this. And so this is just an estimation, to give you a rough estimation, but it's not necessarily the right numbers. So let's look at first what is needed. Let's hear, which is the aperture. Let's assume we want a 30 degrees field of view, which is 30 by 30 is 45 degrees about diagonal, which is reasonable used field of view. And let's assume the aperture is 2 by 2 millimeters here. So if we take the Etendue approach, which is the product of the two, we have 60 millimeter degree. Okay, that's what we need to couple into the waveguide. That's what the waveguide asks the projector to do. But if we take LCoS, for example, it's a 1 millimeter LED right here. It's Lambertian emission. I took for Lambertian 120 degrees divergence. I don't work steradian. I make it simple, just degrees. And with the homogenizer also degrades a bit the Etendue, so we have 250 millimeter degree. We compare this 60 with 24, we get and square that to the power 2 because it's 2-dimension. Take out the polarization also, so we have 3% efficiency. That's for I'm not taking here into transmittance of optics and all. If we do the same for micro LED and say just general number 5 millimeter size of the micro LED, we get 600 millimeter degree, and that's only 1% efficiency. So we see inherently, because the pupil imaging and the small source of the LED, that the efficiency in LCoS system may be better than micro LED. Although it's more cumbersome, complicated, projector is not as big. That's why everyone wants to move. So let's see how we can improve this efficiency issue. So I put here an example again from a Etendue point of view, and I change the aperture. Okay, I call this one diffractive, and this one, the large aperture, is the geometric. Okay, so in this case, typical numbers may be in the region of 1 millimeter aperture, or just a bit more, but not much. But in geometric, it can be within the 3 millimeter aperture. Okay, so if we need if we project from the micro LED 5 millimeter by 100 by Lambertian, which the numbers I said before, then we get for 1 millimeter 0.25% efficiency. But if we make a large aperture, just factor of 3, which is what geometric offers, we get 2 point something percent efficiency. Assume, of course, 2-dimension, which is power of 2. So we get, all in all, it's a factor of 9 better. And we do see that in experiments. We do it in the systems. Geometric waveguide versus geometric versus diffractive does show, in order of factor of 9, improved in coupling efficiency.